Okay, the next thing we're going to calculate is called head loss. What head loss is the amount of water in feet that we lose due to things like friction. There's a formula for head loss in your formula sheet. So we'll look at that really quickly. So your water supply formulas, head loss is equal to 10.44 times the length of pipe in feet times the flow rate to the 1.85 power divided by the Hazen-Williams constant, which we'll talk more about in a later, to the 1.85 power times the diameter of the pipe to the 4.8655 power. And so we'll go ahead and write that formula. Head loss is equal to the constant 10.44 times the length of the pipe in feet times the flow rate to the 1.85 power divided by the Hazen-Williams constant to the 1.85 power times the diameter of the pipe to the 4.8655 power. All right. And so the first thing that we need to do is figure out our length of pipe in feet. And so that's going to be step number 1 for calculating head loss. So we'll write find L. So the first thing we're going to do to find L is convert our 5 miles to feet. And so 5 miles, we know that there are 5,280 feet in 1 mile. So we'd multiply and we get 5,280 times 5, 26,400 feet. And so that's our first thing we need to do to solve, to find L. The second thing we need to do is we need to look at our equivalent length for generic fittings. And so if we look at this, we can see that elbows for 10-inch pipe have an equivalent length in feet of 14. And so we are going to have 5 90-degree elbows and those account for, again, 14 is the number of feet they get. And so we multiply 5 times 14 and we get 70. Let me double check on my calculator. Yes, 70 feet. And so those elbows are accounting for 70 feet of pipe. We also have one 45-degree elbow, and if we look at our equivalent length sheet, I'm looking at regular 45-degree right here. Bring it over to 10-inch, and it accounts for 9 feet of pipe. And so we'll add all of those up to find L. This number, and this number. L is equal to 26,400 plus 70 feet plus 9 feet. We add those up and we get our L. So 26,400 plus 70 plus 9 equals 26,479 feet. And so that is the amount of feet we have in our system. So now we'll use that Hazen-Williams constant formula. And so I'll go ahead and write it over here. The head loss, or not, excuse me, the head loss formula. Head loss is equal to 10.44 times L, which we just solved for, 26,479, times the flow rate, which the flow rate was 120 gallons per minute. And the flow rate is to the 1.85 power. We divide that by the Hazen-Williams constant, and so let's look at that. Here's Hazen-Williams constants in your formula sheet. For cast and wrought iron pipe, the typical range is 80 to 150. If it's new or clean pipe, 130 is the number you use. And they give us a typical design value. And so we're always going to use this typical design value in this class. And so they give us that number of 100. And so for our cast iron pipe, we're going to use a typical design value of 100. And so I'll go ahead and write that in, 100, and that is to the 1.85 power. And we multiply that by the diameter of the pipe, which this pipe is 10-inch diameter, to the 4.8655 power. All right? And so it's just a matter of calculating with your calculator, hitting compute. So I'll type in 120. If you didn't know it, this little Y to the X button on your calculator will allow you to input an exponent. And so 120 to the 1.85 power equals that. I'll multiply that by 26,479. I get that. I'll multiply that by 10.44, and I get the top part of my equation, 194,127,6438. Divided by the bottom half. Again, I'll use 10, hit the Y to the X button to do an exponent, 4.8655. I get that number. I'll multiply that by 100 to the 1.85 power, and I get 3677,053.4. So I'll divide those two things, 194,127,6438 divided by 3677,05393.4, and I get that I am losing, I have a head loss because of the friction in the pipe of about 5.28 feet. And so our head loss is 5.28 feet for that pipe. And so what that means is, because the pipe is made out of cast iron, because there's friction involved, because it's a 10-inch diameter pipe and we have 5 elbows, a 90 degrees and one 45-degree elbow, we are going to lose 5.28 feet of water. And again, head is the amount of water, if we connected a cylinder to our source, that it would raise the water that many feet.